Hello, geometry. I'm going to go over a couple examples from section 9.4 and section 9.5 dealing with angle of elevation and angle of depression. So turn to your student journal on page 259, where we need to fill in the definition for angle of elevation. So you can write it down right along with me. So an angle of elevation is the angle that an upward line of sight makes with a horizontal line. Okay, so for example, if this is the ground, so if this is the ground and you have a person standing here, right? I'll give them arms. So if they are, here's where, if they were looking straight ahead, it would look like this, right? But if they were looking up, they would look this direction. Like maybe if they were looking at the sun, right? Probably they assume they have sunglasses on. Okay, so the angle of elevation is this angle. I'll call it X degrees right there. Now, the reason why this is part of this section is because what we can do with this is between their straight line of sight and the line of sight upward, if I connect those, I have now a right angle. So that's why it's part of this section, because we can use trig ratios to help us find, how high up someone's looking at something, like maybe there's like a bird here that they're looking at, or the top of a building or a top of a tree. So we can use trigonometry to be able to find things like this height. And assuming that this was a tree, just giving you lots of examples, we could also figure out how far they are from the tree, right? So there's different things that we can do to help us solve these things, and we would use trig ratios to do it. Okay, so let's do an example. So we're going to turn our page to you're going to turn to page 261. We're going to look at number 9. So it says a boy flies a kite at an angle of elevation of 18 degrees. So here we see angle of elevation in our problem. This is also going to be really important to remember. It says the kite reaches a maximum height, so height, of 300 feet away from the boy. Maximum height of 300 feet away from the boy. And then it says, what is the maximum height of the kite? Okay, so and remember, so this is the maximum height 300 feet away from the boy. And what we're trying to find is the height of the kite. That's what we don't know. First thing you're going to want to do is to draw yourself a picture. So that's what I'm going to do first. So I'm going to draw my little person here. I'm not going to do number 10, so we can cross that out and use that space if you need it. So I have my person. Here he is. Okay. And it says that he's flying a kite. Okay. And so there's a kite up here, right? So here's my kite. It's a pretty kite. Okay. So here's my kite that he's flying. Okay. Obviously, it's going to be attached by, that's not really where my string is going to be going, right? This is going to be my string, like this, right? There it is. That's better. Okay, so there's my kite. All right. It's and then we also have the line of sight here. which is going to be parallel to the ground right here. Okay, so the angle of elevation is the line of sight upward. We also have the line of sight straight if the person was looking straight. Okay, now they're saying that the boy flies a kite at an angle of elevation of 18 degrees. So that 18 degrees is representing the angle from, in comparison to this straight horizontal line of sight, how much upward they're looking, right? So I'm looking up at a degree of 18 degrees. So that's going to be this angle right there. Okay. Now remember, this does create an effect of having a right triangle if I draw these imaginary lines here and here. Okay. So again, angle of elevation is the upward line of sight with the horizontal line. Here's our horizontal line. Here's the upward line of sight. There's your angle of elevation, 18 degrees. I can sort of create this imaginary line here to connect this vertical height with the horizontal line to create my right angle. Okay, so let's talk about the other information that we know and label it in our picture. So it says the kite reaches its maximum height 300 feet away from the boy. This does not mean the maximum height is 300 feet. It means that it reaches that maximum height when it is 300 feet away from the boy. So this right here is not 300. So here's the maximum height. It reaches the maximum height when it's 300 feet away from the boy. So that means that this is going to be 300, not this over here. Okay. And then it says, what is the maximum height of the kite? And I wish they were a little bit more specific. Is to be the maximum height the kite is above the boy. Okay, so we're gonna assume that like this height right here is not being counted. So we're gonna do the maximum height of the kite from the top of the boy's head, like I have drawn there, sort of, right? So what we're finding is this value here. Now, with this, we can see that we know information about a leg and we know an acute angle. And the other side that we're trying to find is also a leg. When we think about SOHCAHTOA, we think that, well, sine and cosine have something to do with the hypotenuse. Notice that our hypotenuse here, we don't know anything about that. So I know I'm not going to use sine and I'm not going to use cosine. So therefore, the one that is left is to use tangent. Okay. So we have tangent, 18 degrees. Okay. And then we're going to do opposite leg over adjacent leg. So that's going to be h over 300. So when I go ahead and cross multiply, so putting this over 1, remember this sticks together. 1 times h is h, and then it's going to be 300 times tangent 18. And then I'm going to go ahead and go to desmos.com and put this into the calculator. So again, that's going to be tangent 18 times the 300. Whoops, I messed that up. Okay, so that's going to be 97.47. I believe they wanted you to round it to the nearest tenth. That's 1 decimal place. So that's going to be 97.5, and the measurement is in feet. So that will be your answer to number 9 in your student journal on page 261. Okay, so that's angle of elevation, looking upward in comparison to some horizontal line. The horizontal line could be the ground. It could also be the person's horizontal line of sight compared to its upward line of sight. Okay, now we're going to switch over to section 9.5, So you're going to go in your student journal still, and we're going to look at number 14. But let's go ahead to the beginning of this section and write down the definition for angle of depression. So angle of elevation was about looking up. Angle of depression is sort of the opposite, right? So angle of depression is the angle that a downward line of sight makes with a horizontal line. So this one is, is looking down. All right. So, for example, if you have some person here, I'm just making this up. So here's their horizontal line of sight, but maybe they're looking down a hill. So maybe there's a hill right here and their friend is at the bottom, right? And so they're looking down at their friend, right? And so that as they're looking down, it creates an angle with that horizontal line of sight. This angle right here, I'll call it X, is your angle of depression. It's the angle of where you're looking down compared to some horizontal line, which could be possibly eyesight or something like that. But that's just a quick little example, okay? All right, let's go to the example. Number 14. Okay, we're going to do part A. Now this one, drawing the picture, is a little bit confusing. I think the ones in your homework are a little bit easier to understand. So I'm going to take you through drawing the picture of this one. So there's a little bit of information here. It says they have some camera attached to a kite that's filming some damage, right? This must have been before they had drones. So that was caused by a brush fire in a closed off area. The camera is directly above the center of the closed off area. I guess you could also think of a drone as being sort of like a camera attached to a kite that doesn't have a string, if you can find some relation there. All right. So this is what we have going on. We have this, we have this person, okay? And we have this person is flying a kite again. So here we have our string of our kite. I'll put little bows on it so you know it's the string of the kite. So here's my kite. Okay. And then we also have this person that is standing away from the center of this close off area. So right here, I'll call this the center. So a little confusing. But remember that is parallel to their horizontal line of sight like this. Okay. So it's not a very straight line. Let me try that again. Okay. So so that's what we have so far. Okay. Sorry, that kite is above the center of the close off area. So we'll put it like this. There we go. Okay, so a person is standing 100 feet away from the center of the closed off area. So they're saying that this person is 100 feet from the center of that closed off area, right? So if this horizontal line exists here, that horizontal line also can exist like this. Right? We can have a horizontal line anywhere. We can draw an imaginary horizontal line wherever we need to draw it, like that. Okay? So that means that if this is 100 from here to here, that means that this is 100 from here to here, which means that this is 100 from here to here. So this is also 100. I know, It's a little, this scenario is a little bit confusing. So that's why I'm going through it. It says the angle of depression from the camera to the person flying the kite is 25 degrees. So the angle of depression is coming from the camera on the kite, not from the person. The person's not looking down, the person is looking up. But imagine the camera, if the camera was looking down at the person, it would create this downward line of sight with some horizontal line, right? Some straight horizontal line that we can create from the kite. This right here is your angle of depression. So let me draw that in right here. It's right here. This angle is your angle of depression, which is 25 degrees. Okay. So then it says, how long is the string from the kite? How long is the string on the kite? Okay. So here's my string on the kite. So that's going to be my X. Okay. So this is what I have going on here, right? And you have to imagine that you could create some other line here to put your right angle there. So if you're wondering, where's my hypotenuse? Well, the hypotenuse is always going to be that upward line of sight for angle of elevation. Or it's going to be that downward line of sight for angle of depression. So that's going to be always be your hypotenuse. And that's the one in this picture that we don't know. So again, thinking about SOHCAHTOA, okay? So thinking about SOHCAHTOA, I'm looking at my angle here, right? My angle is 25. I'm trying to find the hypotenuse. So it's definitely not going to be TOA because or tangent, because we need the hypotenuse, okay? So let's see if the leg that we have is either the adjacent or the opposite. If it's opposite, we're going to use sine. If it's adjacent, we're going to use cosine. So from 25 degrees, the leg that I know is adjacent. So that tells me that I'm going to use cosine to solve this problem. So it's going to be cosine of 25 degrees equals the adjacent leg over the hypotenuse. So we would go ahead and then solve this through cross multiplication. So it's a little two-step here. So just going through the steps of solving this by cross multiply, divide by the cosine to cancel that out. So x is 100 over cosine 25. So I can go to my calculator and do 100 divided by cosine 25. And I can see there is my answer, 110.33. I think they wanted one decimal place again. It doesn't say, so I'm going to go with one decimal place, 110.3 feet. So that would be your answer. Now, this was a little bit more of a complex picture. So when you're doing your homework, if you just need help drawing your picture, please let us know so that we can help you out during support time. So now you're going to go to Big Ideas. You're going to do your Big Ideas assignment. I hope that this information helped, and best of luck with your practice.